Hey, before we begin, I want to thank the sponsor of today's episode, RevenueCat. RevenueCat has made it easier for app developers to build, analyze, and grow in-app purchases and subscriptions on iOS, Android, and the web. There's no server code required. With a few lines of code, get in-app purchase infrastructure, analytics, and integrations without managing servers. When you're building an app, you want to focus on your app, the design, the look, and being able to take a look at how your users are using your app. What RevenueCat does is it takes that burden away. It makes in-app purchases easier. With their automated reporting tools, you get out-of-the-box analytics for key subscription metrics. This gives you the insight you need to grow your app. There's subscription analytics, customer lists, filters and segments, and all sorts of plugins with different APIs so you can get started and analyze your customers and get a hold of them today. Focus on your app and your design. Go to RevenueCat.com to check out how to get started today, as well as their YouTube channel in the link below. They show you how to get started whether you want to use a CocoaPod or Swift package and integrate RevenueCat into your app. Also, you'll want to check out my episode with Andy, who talks about some of the new stuff that's come out with StoreKit 2. Now, it may make it a lot easier for you, but RevenueCat is going to make sure that you have that long-term growth and being able to look at how your app works and how subscriptions can be used and utilized for greater income. Try RevenueCat today, and thank you again, RevenueCat, for sponsoring today's episode. Welcome to another episode at Empower Apps. I'm your host, Leo Dion. Today, I'm joined by Shai Mishali. Hey, Shai, thank you so much for coming on.
Hey, Leo, thank you for having me.
This is going to be a very special episode because, as you might have heard, I'm recovering from COVID. So if I sound slightly congested in the audio today, you'll know why. Luckily, I'm doing okay. I got my hot tea this morning. So thank you so much for joining on for today's episode.
Yeah, absolutely. I'm glad to hear and see that you're feeling better. That's very reassuring.
Yes. It's coming around.
That's good.
So I've been wanting to have you on for a while. I've been trying to get another opportunity to do a reactive episode. And then I heard about this book that you tweeted about that you're doing with Ray Wenderlich on Expert Swift. Mm-hmm. And I'm like, oh, good. I want to do a topic on it. It was Advanced Swift at the time, but same idea.
Yeah.
What's Advanced Swift? But before we get into that, I want to let you introduce yourself.
Yeah, sounds good. So my name is Shai. I'm from Israel, and I do iOS, I guess, for about 10 plus years at this point. Started about at iOS 4. Used to do 8 years of backend and web development before that, and kind of switched over at some random part of my life. Currently doing iOS from Monday.com. And doing a lot of open source work on Arc Swift, combined related project, reactive stuff, as you can imagine, and writing and editing a lot of books for Ray Wenderlich as well, which has been a ton of fun as well. Some of them are the combined book, which is the first one that was released probably on iOS, on the iOS community. And we have this new Expert Swift book, and we have another upcoming book, which we'll probably talk about a bit later. And that's mostly it.
So let's get into it. What does that mean, Expert Swift, to you?
I'll start by saying that, the initial version of the book was called Advanced Swift. We just had a conflict with the naming that was super accidental and unfortunate, so we decided to rename it at the last second. So for me specifically, I think that when you start learning Swift, you kind of learn the language features and how to build apps. And you do that for a while. And after a couple of years, especially as you switch jobs and work on a lot of different projects and work with a lot of different people, you kind of gain this experience of how you can leverage more advanced language features to really structure your app differently or think about things differently. And that's kind of what I have in mind when I think about Expert Swift and Advanced Swift topics, just kind of topics that usually don't get enough credit and definitely don't get enough book coverage, in my opinion. Like topics like Reactive or topics like Codable, going a bit deeper into it. Even though there are books about that topic, we kind of wanted to do an entire book that if you already feel pretty proficient with iOS and Swift development, but kind of want to take that next step, that you could kind of dive into that.
I'm trying to figure out the best way to put it. One of the traps that those of us who are software developers can run into is over engineering things. Do you think there's some traps with being an expert in this stuff where you start throwing in associated types and like overdoing it and then making it a challenge for more novice developers to pick up your code and like maintain it, I guess?
Yeah, I think it's definitely a challenge. I mean, from one side, I think Reactive goes into that area a lot of times. People would sometimes say that our Swift code bases are a bit heavier to learn through. So I think part of being expert or more advanced developer is also being a pragmatic developer, trying to understand what makes sense and what doesn't make sense. Sometimes you might want to do something that isn't the optimum pure Swift code amazingness, however you would call it, but it makes much more sense for your fellow developers. And I think that with time, as you work with a lot of companies and you work on a lot of projects, you kind of develop these instincts. You can't always be a purist. So it's really a balancing act. Definitely a lot of tools in any programming language, but especially with Swift, the number of kind of language features grew exponentially over the past few years, that you kind of need to be careful reaching for the fancy new tool every time just for the sake of using it. So I agree there is some problem there, but it really depends on the team and how do you define yourself as a developer, and if you can kind of go beyond just saying I want to use the latest features and think about why am I using this and who would be the consumers of these APIs that I'm designing right now.
Yeah, exactly. I think that's a good way to put it. And just not like being an expert means being a good teacher too, and being like, okay, this is a pattern. Like, now do you understand like how we apply it?
It is really like the word senior in titles, right? Like people think senior is just being advanced in your profession, but it's really about, can you be a good mentor to people that just started doing whatever you do?
Yeah, exactly. Well, let's get into the first big topic that you covered in the book, Codable. I guess there's kind of layers to being advanced at Codable, right? Because you can do stuff like coding keys, you could do stuff like custom encoders and decoders, custom, inits and decoding. What do you think are the good first steps for anybody who's going to really get into Codable, and why is it beneficial to them and their team?
That's a really good question. I think that, first of all, Codable is a pretty amazing tool. I mean, I'm now working on different projects where I'm using YAML, and I use the same code, like encodable, decodable conformances, and just switch the decoder and everything works, and it's pretty amazing.
Yeah.
So I think that specifically with this book, we kind of plan on doing chapters that go 20 pages a chapter on these topics. And every time we try to make the 20-page chapter, we accidentally made 40 pages because there's so much to learn about. Yeah. Like this entire book is full of 40-page chapters, which is like twice the maximum we usually allow to write in Ray books. Yeah, which is pretty funny. I mean, we always laugh. Our editors always laugh that we went crazy on this one. But to your specific question, I think that the leap between just knowing the basic Codable stuff, which is I'm going to make a struct, conform to Codable, and the fields are going to match exactly to what my server returns, is really anything beyond that. And I think that's really reality, right? Most of the time, our API isn't going to be not necessarily, like the backend APIs aren't going to be necessarily aligned with what we want to achieve in our clients.
Right.
A lot of times we might want to decode things into primitive types like an enum or something that doesn't necessarily make sense in the structure that it comes from the database. Sometimes the keys aren't going to match, or the structure is entirely not going to match. I think those are the areas where Codable, you can get fancier with Codable. Like you can work with generic decodable structures, or you can work with custom coding keys or custom coding strategies. And I think those are the areas where it's interesting. And really, to the second question, I think of why even bother with Codable, I think we pretty much answered that. It's a really relatively simple way to define how to go in and out of a sum type. And the fact you can have many variations of Codable for JSON, for YAML, for binary JSON, if you're on the MongoDB team, that exists as well. So I think it's really nice that you have a single interface to kind of unify all of these decodings and encodings.
What do you think, at what point is it worth just having an abstraction built on top of a type as opposed to custom decoding, encoding of whatever you communicate with the server with? Does that make sense?
Yeah, I think so. I think that it's pretty, I don't know if it's pretty common, but I think that it's easy to bump into these scenarios where you would try to make a decodable conformance and you would just hit a wall because it just wasn't necessarily meant to do the thing you are trying to do at the moment. And at those moments, maybe you would just make a custom initializer and decode just something a bit higher level, or decode it into a manual dictionary if you really have to and really go deep into the data. But I think those are less common scenarios. I think most responses that I know can easily be not easily, easy or hard depending on the response, can be decoded into Swift types. I mean, in the book as well, we go kind of from 3 different responses where the last one is just insane and incomprehensible and doesn't really align with any RESTful API standards. It's just kind of a mess, and we can get that to go into Swift as well without manually doing too much stuff. So it's really about figuring out what are the points of friction and how can you solve it inside the decodable conformance frame. Yeah. But I agree that sometimes it makes more sense to just use a higher abstraction if you really, or even a lower abstraction, right? If you really don't have a choice to do so.
What other things do you think developers just don't know about when it comes to Codable and custom stuff with Codable?
I think there are a lot of small corners. I think that, for example, like custom decoding strategies are a bit of a weird thing that is easily kind of skipped by developers, but it's very common that you might need that and solve it in a different manual way. Also, another one would be coding keys. I mean, sometimes you would have a coding key, and that would need to be a finite set, right? Like an enum of coding keys. And sometimes your server response doesn't work that way. Maybe your keys are dynamic, so there are ways around that as well, like making custom coding keys and trying to figure out how coding keys work to begin with. I think those are kind of hidden details that aren't discussed too much.
So as far as like coding keys, a couple of questions I had was like, when is it worth using custom coding keys as opposed to like just changing the encoder to say, hey, don't use snake, use camel or whatever, or like use uppercase or lowercase? Because there's a few options in the actual decoder where you can change that as opposed to changing it in the coding keys.
Yeah, so there we're when you're talking about that, you're talking about what's called a key decoding strategy, which is like the strategy that the decoder uses to decide how do I take the key that comes from the server and match the name of that one to the name of a property on a struct, for example.
Right.
And the default is just using the regular naming, as far as I know. And the most popular one after that would be like convert from snake case, probably. I don't remember the exact case on that, but it's probably converting from snake case. And I think those are two of the most common cases, but they're not always enough. For example, there are still some APIs that might have mixed conventions, which is like super painful, but it happens, where you would have an API that kind of works with both of these variations at different times. You might have like APIs work with Pascal case, APIs work with kebab case. There are so many weird variations. And I think those are the scenarios where that happens. And if we're talking about coding keys specifically, as I mentioned before, sometimes you can't know in advance what's going to be the final list of keys that are going to be in that structure that you're trying to decode. Sometimes, like there's an example in the book where the keys are a list of dynamic dates. So not only you have to figure out the keys at runtime, you also have to decode these dates as actual Swift dates. So it can be a pretty challenging task depending on the on the response. And I think a lot of teams sometimes build their own server interfaces, what's called a BFF, to kind of go around that, a backend for front end.
Yeah.
But we can also solve these things on the front end as well, in my opinion.
So with the case with the date, is that a key amongst other keys, or is it like, could you just use a dictionary of date to whatever the value is?
Yeah. For example, it's you can do a bunch of things. It depends on the example. In this specific example, it's like a dictionary from dates to structs.
Okay.
And you would want the struct to contain the date as well.
Okay.
So it's a bit complex. I think the example itself is actually public on the Ray Wenderlich repo. Actually, all of the materials are public. The book themselves cost money, but the all of the code and stuff is public on the GitHub repo. So if anyone's interested in the example, they can poke at that there for sure.
Yeah, and we'll post a link to that in the show notes as well.
Yeah.
So let's jump into another topic that I just talked about in the last episode with Daniel, and that was dealing with Objective-C. I'm curious about the inspiration for this, first of all. But then, why is it important? I mean, I know why it's important, but I want to let you
my perspective
weigh in on why
yeah.
Objective-C is so important still in 2021.
Yeah, I think that, like, for me, it's two questions. Like, why is Objective-C so important, and why is it so important to make it work well together with Swift? So for the first question, Objective-C is still not dead, as opposed to what many relatively newcomers to Swift like to think. It's in most big apps that exist for more than 3, 4, 5 years, there is a substantial amount of Objective-C code. I think that almost every job I've done, except for 1 or 2, had a lot of Objective-C code to this day.
Can you disclose if Monday, do you guys have
Objective-C code? We have a lot of Objective-C code.
Okay,
for sure. Okay. I mean, we did a lot of cleanup there, but I can easily tell you, like, that a lot of big apps out there would have. I'm sure Slack has it. Like, even consider, like, Twitter has a lot of it as well, I'm sure. Yeah. Just consider open source projects by these companies. A lot, like LinkedIn, have their own open source project for doing some stuff that's in Objective-C, so you can assume their code base has a lot of Objective-C as well. So I don't necessarily say that you need to develop new things in Objective-C. It is a relatively older language, and there are newer, better statically typed tools to deal with modern tasks. But it is still a lot of code out there that uses it. And the second thing is that up until, I think, a year or two ago, and probably until this day, Objective-C is still considered the best way to ship SDKs by third-party vendors, because of the fact that earlier on you couldn't build a framework with binary module stability in Swift. And that changed a few Swift versions ago.
Right, with the XC frameworks.
Exactly. So you can have you can really move it between different versions of Swift, which made it super cumbersome to work with. I saw a couple of companies that were courageous enough to try this, and eventually they would just need to ship a new version of the SDK every minor patch or every new version of Swift. And the consumer would have to pick the right version for their project. Or if you have 100 developers and each of them works on a different version of Xcode for some reason, then you're in a huge pile of trouble.
Yeah.
So not the best experience as well. So those are reasons, I think, were like really solid reasons to use Objective-C, even to this day. And about Interop, I think it's like just a super interesting topic, because there are so many tools to kind of blur the line between Objective-C and Swift today. so that you can build APIs that when you use them inside Swift, you wouldn't know they're Objective-C unless you really go into the header files.
Yeah.
I think that today we have enough good tooling to do that, and it's really exciting because before that you would do a lot of wrappers in Swift to wrap Objective-C types or stuff like that, and today you need to do that less often, I think, which is pretty great.
Yeah. So that's like pretty much my day-to-day bread and butter is migrating Objective-C over to Swift right now. And like there are a lot of first steps that you can make in your Objective-C code to make it easy to move it over to Swift. And the lowest hanging fruit, in my opinion, is nullability. Do you want to explain what that means exactly?
Yeah, sure. In Swift, everyone that kind of learns Swift takes for granted the fact that you have a type called optional, and that's this question mark thing you put on types, and that basically means that the value might or might.
Yeah. That was like the first big, like when Swift came out, that was like the first barrier that a lot of Objective-C folks had to get over is why do I have to put this exclamation mark
question mark everywhere?
Yeah. Sorry, I just wanted to say that.
No, you're right. It's like trying to throw a JavaScript developer into TypeScript. Like, why do I have to put types everywhere? It's like, it's a type. It's a typed language. That's exactly it. So in Swift, you can annotate something with a question mark that would make it optional. That means that the value might be there or it might not be there. It's optional, obviously. And that's kind of what makes Swift nice and like powerful in a strictly typed language that you can design these concepts. Objective-C wasn't built around that idea from the compiler level. It's more of a runtime thing. That means that nullability in Objective-C could just randomly happen. You don't really have a way of knowing that because in Objective-C, when you define a property, for example, and you access it, you don't have any compiler features that make you unwrap that value, for example. You just access it. You might crash if you don't do the proper checks before. That's basically how it works. And then later on, when Swift came out, we got all these nice annotations for Objective-C to help bridge that gap. Like NS, like nullable or non-null or assume, begin, assume null and all of these things. And that kind of aims to both for Objective-C and Swift actually to say this specific property might not be there. Like trying to achieve the same notion of the type system on Objective-C. And I think that's really cool. It's super painful to do that migration because once you mark a single property, it makes you do all of them.
It lets you know. It lets you know, yeah.
Yeah, it lets you know. So if you have like a huge model or a huge class, which is what most Objective-C developers would have, and you want to just kind of work on that one property, you're pretty much going to get a bunch of warnings unless you don't fix everything.
I actually appreciate that discipline because I mean that's kind of the gold standard where I want to head, and if it means more exclamation marks, at least I know like what I can fix in the future. So I agree. So there's like nullability on parameters, nullability on return types, and then there's nullability also when it comes to like properties, where you would have like a property in Objective-C, you'd say strong or assign or whatever. You could also say nullability in there as well. I'm trying to think where else, but that's like pretty much the idea.
Yeah, I mean, it doesn't do anything on stuff like that.
Right. It doesn't do anything on the compiler side. Like if you throw in a null, it's still, it could still be null.
Yeah, but I do believe though that in Objective-C, I don't remember off the top of my head because I didn't mess with it for a few weeks now, but I do remember that if you would define some field as nullable, then even in Objective-C, it would warn you to check if it is null before accessing it because you did annotate it with that non-null argument, for example.
Okay. Does that make sense then? Yeah. The other thing that I didn't even know was there in Objective-C, and I don't know how late that's come in, was generics. That's another thing that's been super helpful because, even I've been saying, I remember the early days of Swift, we didn't have generics. And we were still using NS array and NS set and NS mutable and all that stuff.
And casting everything,
Yeah, right. And then they added generics to Swift and to Objective-C. And that's big help because like now it's not strong typed. I don't want to use that word because Objective-C is a different type of language, but like that helps Swift developer a lot in knowing like what actually is going on underneath the hood with whatever your collection or generic type is.
Yeah, I agree. It also helps inside of Objective-C because since they added that syntax, then also when you are enumerating an array, you would get the typed version of the object inside of that closure or block if we're talking Objective-C here.
Right.
So it's pretty useful, I think. I think it was a huge addition. I mean, they call it lightweight generics, which is a bit funny because it does almost everything that the regular generics do. I mean, you can't, I think the big upside, like downside is you can't extend them in this and compose them in the same ways you can inside Swift.
Okay.
But if you want to make a class that's just generic over some type, then you can do that pretty easily with Objective-C, which I agree you couldn't do a while back. Yeah.
What am I missing? Feature. Nullability, generics. Was there anything else you talk about in the book that you would recommend
there's
folks
a lot of
add?
stuff, but yeah, I mean, I think that there's a lot to cover there. 40 pages of content, as I mentioned, for each of these topics. But I mean, another big one is just a Swift name, which is like super, super useful. There are a lot of hidden corners there. But yeah, I mean, you want to make I think that the runtime and the Swift compiler are doing a pretty solid job converting these names, but sometimes it's really hard to figure out. So it's important that you know that a Swift name exists there so you can
rename
give a proper name for your, just rename for your properties, methods, whatever. There's also NSRefined for Swift, which is super useful, which is basically, for example, you make a class and that class makes sense for Objective-C, but it really doesn't make sense for structs, for Swift. So you can say that it's refined for Swift and then it would hide it inside Swift so you can make your own version of it that's specific to Swift. There are a lot of useful little hidden features around that I suggest learning about. It's really interesting.
So refined, you can hide an Objective-C class?
Yeah, like you would hide it from Swift. Swift, like if you would try to type the class name or object name, whatever, it would not show it in autocomplete.
Wow!
And it does this. It does this nice trick where if it hides it behind 2 underscores. So if you have something called person, you can in Swift write _ person, and you can access it, but you will not get any autocompletion for that, which is really, really interesting. I mean, when I first learned about it, I found it super. Like I'm doing something really pretty fancy with it in the book. Like we're taking this Objective-C SDK and we're wrapping it inside Swift UI observable object. And we're doing this by refining the inner class, which is really, really powerful. Yeah, it's really, really nice. It also kind of reduces this notion that you have to rewrite everything in Objective-C. There are a lot of ways to get around that.
So we had a few questions from Boss, but one was, are there any gaps in Objective-C and Swift Interop that you feel would improve interop between the languages?
That's a really good question. Thanks, Boss, as usual.
First, any thoughts on that? And then B, do you think Apple would ever spend time implementing any of those?
So I'll start from B because that's easier. I like the easier question. I think they constantly do. I mean, first of all, I think that Apple are still doing a lot of Objective-C themselves. And the second thing is that like there were sessions this year in DubDub about Objective-C that were really, really good.
Really?
So I think that, it was either this year or last year. I mean, I kind of lost track of time with COVID. Not entirely sure.
Right.
Yeah, everything kind of, everything feels like a big lump of time instead of years at this point.
Yes.
So I'm not too sure. But yeah, they're still investing a lot of time on it, I think, trying to make the interop good. I think that the big barrier there is just value types. I don't know if you can really bridge that stuff. That would be amazing. I mean, that you would be able to define something that behaves like a struct in Objective-C, but it's just not the way the language itself works, and C itself doesn't have that notion probably.
Well, C has value types, doesn't it? I mean, it has
Yeah,
structs.
I mean, it has value types, but it doesn't have them in the sense that Swift has them.
Okay.
They're more like a bag of data with structs in
it's
Swift
literally
can have
written into
capabilities.
memory, like in that order. Yeah, I know what you mean. Right.
Yeah, I think in Swift, structs can just have a bunch of capabilities and computed props and like generics and a lot of stuff that are like super, super nice. And second thing is just there are things that are a bit harder to breach. Like, for example, if you make an enum in Objective-C, even if you annotate it with NS-typed enum and all this stuff that makes it visible in Swift, then you can't make it case iterable, for example. And so you have to kind of make custom extensions on it. Yeah, so it's like small things. I think that really it's come a super long way. I'm pretty happy with the Interop there. I think you can do a lot of really interesting things with it today.
Yeah, I think like for me, like the value types really hits it on the head because like I've been doing some stuff where like I'll write a value type in Swift and I'll just end up like creating a class, an NS object class that has a value type inside it, like basically wrapped. And like I basically am like replicating the functionality with the same struct type underneath because like I don't want to sacrifice both, but at least I want that value type available in Objective-C. And like that's just
I agree. It's a huge pain. I also think that with Swift we got spoiled like because value types are so powerful that you don't have to think about corruption of data and stuff and releasing memory and weird stuff like that. So it's like we got so used to that super powerful kind of data structure that it's kind of hard living without it in Objective-C.
Right. Okay, let's jump into API design tips and tricks. Well, first of all, what is API design in your opinion, and how do you cover it in the book? I'm really curious.
So I always say that API design is probably only second, like for being an opinionated topic, as naming variables. Like it's such an opinionated topic, right? Like you would never find like like people in the same room that would have the same opinion about that. But in my perspective, is about if you are making a piece of code, what is the public interface of that piece of code that your consumers would actually work with, and how do you make it the most pleasant as possible so your consumers can easily discover, play around with it, it makes sense to them, that it's expected the way it behaves, and that it's easy to maintain and read and all of that stuff. I mean, there's a lot of stuff in there, right? But that's basically how I look at it. Okay.
So yeah, we had Ann Callahan on talking about how like designing public APIs and making it like one of the things that she recommended I really like is like taking a break from it and then looking at it again later as somebody who forgot like what they were working on, and that like really opens her eyes into like how like somebody else might look at it as well. You know, obviously code reviews and things like that help. Just getting
that's a really amazing. Yeah, that's a really amazing idea. I think that it's pretty good for apps as well, right? You're always going to have a better idea if you're going to leave it for a week and then come back. You're like, who wrote this garbage? And I did. You know, right?
Exactly.
Every time. Yeah.
So a couple of things I saw in the book was encapsulation and versioning. You want to explain how those work when it comes to API design?
Yeah, sure. I mean, when we're talking about encapsulation, it's just really a deeper dive into what I just mentioned, which is only kind of share the minimal stuff that your consumer has to know about your API, which is just like if I want to get some items, then the consumer would only get a get items method. They don't necessarily have to know what happens inside, how it happens. Are you using combine? Are you using dispatch queues? Are you using async await? Like mostly it doesn't matter. It's implementation details. So I think first and foremost, it's about how you separate between your interface and your implementation details. That's really about encapsulation.
So kind of like abstraction, like trying to hide stuff that just makes it more complicated than it needs to be.
Exactly. Abstraction is exactly that, plus the concept of generalization, which is like I'm trying to take a group of properties that are shared amongst a bunch of objects and generalize that under a protocol, for example. That's kind of more how I look at abstraction, depending on how you like what you use that word for, because abstraction is also a pretty overloaded term. And for versioning specifically in the book, we're talking about it in the notion of managing like open source projects or just public projects where the versioning matters, where you have semantic versioning and every change you make to the version count is super, super critical because you have consumers that depend on different versions. And just about knowing when to change each version, when each component of the version is changed, and also a bunch of metadata stuff you can add to the version to kind of semantically help package managers deal with it. So those are two topics I'm kind of talking about in this topic, but it's really more about an exploration. Because it is a very opinionated topic, this chapter is less about look at how you do all this stuff. It's more about look at some of these ideas. You might not like all of them, but maybe you can gain some inspiration from some of the thoughts we are going to discuss in this chapter. That's kind of how I look at API design in general. It's kind of like a collaborative process.
What do you think are some of the biggest mistakes folks make when it comes to versioning?
I think it's just really easy, especially early along the way, to just do a lot of major version bumps or just make breaking changes without properly bumping the right version component. For example, if you have someone depending on 1.1 and you change the API completely and release 1.2, they're going to get that update and they would not be a happy camper after that. I think that's a very common mistake that I see, especially in relatively. You can be super expert at Swift and not necessarily have expertise with shipping public libraries, for example, because it's not something that all of us have to do, right? So, or even as a consumer, you don't necessarily know. I need to think about versioning this way. This project is a bit flaky with its versioning, so maybe I need to pin the specific version number to not count on their bumps. So I think it really varies how you deal with it.
Yeah. What I do is I just keep it at 0, and then that way, if I change the whole API, I'll say, "Well,
exactly.
it was never version 1, so it's not my fault."
Yeah, exactly. I always like for new project that I do, it's always 0 point until it's like, I haven't changed this project for a year. It can be a 1.0 at this point. It's fine. Yeah, but sometimes it's painful the other way. Like you made like a relatively minor change, but it's a breaking change. Now, do you bump a major version for this change? It's a bit problematic. So you kind of, that's also a thing that kind of changes between projects, but as a rule of thumb, you usually would bump a major version, but rules sometimes have to be broken. It depends really on the realistic part there.
Right.
You just need to figure out how much breakage it's going to cost.
Yeah. Right. So one of the topics I wanted to discuss, I know it wasn't the topic you wrote about. Who wrote about protocols and generics in your book?
Oh, I think it was Marin Benchevic, if I remember correctly. And if not, then fellow authors, I apologize for misstating the name of the author, but I believe it was him.
Okay.
It did a super cool job on it. I think it was really fun chapters to read.
I think like that to me is one of the more advanced topics when it comes to Swift, because people have such a hard time understanding, and it took me a while, how to use generics and protocols and associated types and how they work together. I don't know if you want to give a quick blurb on what you think folks would get. How do I put it? Just like what he does a good job with, I guess, in this book, as far as like explaining this topic and how it would help developers wrap their head around how to use this when it comes to Swift.
I don't know if I can specifically talk to the content of this chapter because I didn't write it, but I can talk about why this topic is generally harder to start with, I think, and how you can kind of get from that hole. I think that generally before typed languages, especially for people coming from Objective-C or JavaScript or Ruby, then you're not really used to thinking in that way. You just have a bag of objects. You put all the objects there. If you need, you cast them later to make them do different things. But if you want like the compiler to guarantee that, for example, an array of this object, all of the items in the array can do that specific action, that's where you really want generics and strongly typed objects. I think that it's a bit of a difficult concept early on. I remember that initially when Objective-C introduced like closures or blocks, I had the hardest time figuring it out. I remember actually that Matt Thompson that worked on AF networking and LMFire answered to me on Stack Overflow. And it was the first time ever I understood that topic. It was just so crazy back then. So I think first tip, just don't give up if you like try to mess with those topics and it doesn't click immediately. And the second thing is really thinking that sometimes you don't really need that stuff. It's really if you're talking about protocols and generics, and the word generic kind of speaks for itself, it's when you want to generalize a problem. For example, there's this open source project I'm doing called Prism that takes like a Zeppelin project and it generates design code in Swift or other languages. And we wanted to add support for other providers as well, for Figma, for example, or for whatever, Storybook. So that's a really awesome use case for generics. You can make like a protocol that describes what a specific provider can do, and kind of wrap that around. But you can also make them separate types if that's easier. But it really depends on the domain of the problem and how comfortable you feel. I think that generally those language features, I get it a lot from I guess less experienced developers, that you can know the tools, but you don't always know when to use them and how to use them correctly. And I think that's really the huge challenge of just getting your hands dirty enough time to really know how to work with them. And I think that from my recollection, that both chapters do a really good job, both on the example projects and the materials. So I'd recommend checking them out.
Yeah. It's a topic it took me a while to wrap my head around, but once I get the idea that like the way protocols and generics work together is, like you said, it's like a suite of types that work together, but all have the same functionality, similar to what you were saying, where you're like with Prism, you want to like, I need something for can't even think of it.
Figma? For Figma.
Figma, or
Figma.
like a different graphics suite. Like you have a suite of classes to deal with each of those cases.
Yeah, and it's really about the fact that when you are dealing with a provider, you don't know or don't care who is that provider, because it is hidden behind of this protocol. You just care it is a provider. It knows how to do this specific set of things. And then each provider to itself conforms and implements the specifications.
So now we get to your favorite topic, functional reactive programming. I want to start by asking Boss's other question. From RX Swift to combine to async stream, what do you think is the future of reactive programming on Apple platforms?
Oh, that's the big one. That's the
big one. The big one. Yeah.
Yeah. I love this question. I mean, I don't like answering it, but it's a really good question. I think that, first of all, I want to start by saying that RX Swift is here to stay. It's not going anywhere. We're, Krinoslav, who initially built it, spent a huge amount of time on it, and I did as well. And I think it's a super cool project that does have a lot of differences from Combine and other variations. So I think it's still a super powerful framework to this day. I think that the journey is pretty interesting. I think that, we had RX Swift that for a long time, folks in the iOS community didn't really care much for reactive programming in RX Swift or Reactive Swift or Bond or any of these other frameworks. And then came Apple and made their own framework, and then it kind of gained more popularity. I think that looking at this past year, Apple didn't make a lot of changes to Combine, which is a bit disappointing. I think they made a really solid version of it, but it's still missing a lot of functionality that other reactive frameworks have today. And I kind of wish that they would spend more time on it. We have a few folks. I also did a lot of work in the open to have Combine Coco or Combine X with a lot of additions to support Combine developers. But it's still missing some tools. But really, like my interpretation of Combine, it was really made to support Swift UI. I mean, with stuff like published and all the observable object, all this stuff kind of relies on Combine to function. So I think that these two things can really work together easily. And I don't think folks should be afraid of switching from RX to Combine as well if it like makes sense for their project and for deployment target and all that stuff. But there are tools like RX Combine, which are also open source, that like let you convert between, so you can still keep working together and convert when the use case makes sense. And then about async await, that's like an entirely huge topic that we've kind of been waiting for a while for Apple to do that. Like, we knew that it's coming, but it's really nice seeing it out there, and it's working really well. I think it has a huge benefit of, like, async stream specifically has this huge benefit that it lets you work, like, iterate over values in a very native for-in loop, which other variations don't. Like, you have to either use sync or subscribe or other variations. So I think it's really, all of them are the same things, but the level of support from the compiler and the diagnostics, all that stuff on async await is pretty good. It kind of keeps you safe, the entire hierarchy of tasks. So I think the evolution makes sense, and I think the evolution is great, really. But I think that the existing tools in that evolutional chain are still being heavily used today. I don't think that's going to change for a while. So I think, and the last thing I want to say about RX and Combine is that if you know one, then you know the other, which is pretty powerful as well. I mean, the concepts are really similar, just some different names. So it's really the same thing. They're both based off reactive streams, pretty much the same concept. So.
Yeah, and I've been following a lot of the work that you've been doing in the reactive world, especially the open source stuff that's out there. I don't know. I'll let you go ahead and explain some of the other projects you've been working on when it comes to reactive.
Yeah, sure. I mean, I think the big one is just RX Swift itself, which I've been maintaining for the past, I think, 2.5 years probably. It's been a lot of fun. I think that I spent a good portion of my time kind of modernizing it, syntax, some of the behavior, stuff like that. But really, it's already a super strong and battle-tested framework that's used by a lot of the, many of the biggest companies in our industry today. So I'm not risking too much there to add crazy functionalities. But for example, now we're adding support to move from observable to async await, that you would be able to await an observable stream. And I think that's like that's awesome. Natural. Yeah, it's a natural evolution that if you are working in the proper deployment target, or whenever we get back, backporting that you would work on iOS 13, you would want to be able to use your existing code and be able to use for value in observable and just be able to iterate all of your values. That would be really cool. And except for that, I mean, for the open source work I do, I think a lot of it revolves around reactive stuff, not because that's necessarily the only thing that I do, but just kind of community that I grew up in iOS, and I have a lot of affinity for it. So a lot of projects around Combine. I think that already into the first 30 minutes of the dub session when they introduced it, I already kind of made the cheat sheet to convert from RX Swift, and we already planned how to make the book. So I think this entire thing, I mean, I have it hanged here on my wall, the bear, that's the book. So, I mean, it's just a cool topic to me because in many projects where it was done right, in my opinion, it just worked really well. So yeah, just every time I see a gap in Combine or in anything else, I try my best to make a good project to work around that problem. So Combine X, for example, provides a lot of operators or functionalities that don't exist in Combine, but might exist in RX Swift or Reactive Swift or other frameworks. While you have Combine Cocoa that kind of works like RX Cocoa. It lets you observe stuff that happens in UIKit components. For example, you can observe a publisher of values from a text fields or taps on a button, and then you can kind of compose all of these different publishers together. That's something that we don't get natively in Combine because Combine was kind of made for Swift UI, so I don't think they consider UIKit so much.
So,
And just basically stuff around that problem.
one thing folks have asked about, well, I think I know the answer to this one, but like, when are they going to open source combine? When are they going to open source combine? And I don't think that's going to happen. But I know that there's some projects out there. I don't know if you've worked on any of the ones where they try to make combine available essentially on older OSs or Linux.
I think that I it's a bummer because I really wish that they would. I mean, it would be amazing. I think that if you go to the Foundation framework, for example, on GitHub, which is open source, like part of it, STD Foundation, you can see some publishers in Combine that are themselves open source, like the URL session publisher, that's open source. There are some stuff, but the framework itself isn't, which is a bummer, especially for Linux users. I mean, I would love it if you could use Combine on a server, for example. That would be pretty awesome.
So I'd really be curious, like, how does that work exactly, reactive programming? Because I'm used to doing it all on the UI, and as somebody else, like, how does that work? What's the use case, I guess, for reactive programming?
You mean for the server? You mean for server programs? I mean, I haven't done much of it myself generally back in development in the past decade, but I have a lot of friends. Florent Pilet, which worked with me on a couple of books, did a lot of projects with server side and RX. And I think that it's just generally treating it just like flows of data. You can have an observable of requests that emits an observable of responses, and you can manipulate it with operators on the way out. Gotcha. So it's really about how you model the data and how you treat that. But I also think that in Swift,
I see async await, like that's easy enough for me to understand on the server, especially with like database calls or network calls. Mm-hmm. But that's cool to see. Like there's folks doing reactive stuff on the server as well.
Yeah, I was about to say that with async await being mostly available on Linux, that would be my natural choice if I would want to do something like that. Right. I think it makes more easy sense today. So I agree. We talked about something else before switching to on the server. I don't remember what was it. Lost my train of thought here.
Oh, just the open sourcing Combine and how that'll probably never happen.
Oh, I just wanted to talk about Open Combine and CombineX, which are like amazing projects.
They are.
Those are like, I mean, those are just like two, I think it started off as two separate individuals, and then it became huge groups of people. They just wanted to make their own open versions of Combine. And basically what they do is make their own versions of all the operators, publishers, subscribers, and then make test suites that kind of compare the results with actual Combine, which is like a super nice way to build it. I mainly think of it as an educational project for me, at least, to look at, but I think there are some folks that use it in production to use Combine in earlier versions than iOS 13. But that's also going to be less and less important over time because we're already with iOS 15. So, I mean, we're already at N-2, what you would call, so less need for that.
Well, my use case, my little pet project is writing a terminal or command line based app and using Combine to update the text on the screen. And being able to do that with like a Linux command, that's been one of my pet projects I've been wanting to play around with. So that's where it becomes useful. Before we close out, I wanted to let you mention about an upcoming book that you're editing.
Yeah, I mean, me and actually Marin Todorov came up with the idea of doing a book about modern concurrency, which is about basically async await, tasks, all of the new stuff that just came out in Swift 5.5. And we've been hard at work on this book for the past few months. It's gonna come out in a few weeks. Actually, it's one of the fastest books we worked on. I'm editing it for him
for a book on async await. That's awesome that it took so quickly because you didn't have to wait.
Yeah, I mean we did the same thing with Combine, and it was so much fun. I mean, it was fun because it's like you don't always know, you don't have documentation as that's like super solid yet. So it's a lot of exploration, figuring it out, and I think that's really fun when you're creating a book or new materials. So we're going to release this book, 10-chapter book, in a few weeks. It's going to be super, super awesome. I edited all of it, and I think that it's super interesting. I learned so much just from reading whatever he wrote, and me and Maureen worked a bunch of times together already. So I'm already used to the high quality of stuff he writes.
This is going to be
fun.
Yeah, I think you guys know what you're doing.
We're trying our best. Yeah, trying our best.
Shai, thank you so much for coming on the show. I really appreciate it.
Yeah, it's been a pleasure. Thank you for having me.
Where can people find you online?
They can find me on Twitter, GitHub, and Facebook as Freak4PC, 4 being the digit 4. Super weird nickname, I know, but maybe on your next episode, I'm going to tell you the story of that.
Yes. Okay, I'm putting that in the show notes for the next episode.
Sounds good. You got it.
Thank you so much for joining us for this episode. People can find me on Twitter at LeoGDion. My company is Bright Digit. Please take some time to post a review on your podcast player. And if you're watching this on YouTube, subscribe and like. Thank you so much, and I look forward to talking to you again. Bye.
Yeah, thank you. Bye.